dividing polynomials, day one, like I said, there are 3 days to this. If you look at the worksheet you picked up on the way in, where's everyone going? Oh. If you look at the worksheet you picked up on the way in, it's separated into 3 distinct parts. Example 1, which says use polynomial long division. Example 2, which says use synthetic division. And example 3, which says find all the zeros. The point of using polynomial long division and synthetic division is to find all the zeros. So the reason we practice this skill and this skill during this chapter is so that we can complete this task. This is Monday. This is either tomorrow or Friday. And this is today. Okay? So these 2 things get us to the same point. It's like factoring or quadratic formula. You have 2 different options there. Okay? I have a preference. One will work for only certain types of problems, and we'll go through that. But just so you know, as you're going through today's stuff, it may seem like a waste of your time at times. And you're like, I don't know why we're doing it. The goal is to eventually solve a function here. Finding all the zeros for a function. Just like you've done with factoring, and you've done with quadratic formula and completing the square. Okay? All right. The other thing that came up yesterday in my other class, just a quick side note. In this problem right here, can I use the quadratic formula for number 22? No. Tell your neighbor yes or no and why or why not. Okay, you know what? Even better, because that could actually yield 2 different answers. Why don't you look at 26? Could you use the quadratic formula for 26? That's a better question. Okay, how many say yes, you can use the quadratic formula? No, you cannot. Okay, so we do not look like a very decisive class. Okay, is it a quadratic? A quadratic is what degree? Second degree. If it's not a quadratic, can you use the quadratic formula? No, it's not a quadratic. Okay? Now you can factor it. You can factor that one. You can't use the quadratic formula. Now I've seen a couple students already trying to use the quadratic formula on this. It only works for second degrees, man. Hence the name, quadratic formula. Okay? All right. Anyway. So, the goal today is for us to use polynomial long division to help us find all zeros, especially or including those complex ones. Okay? So here we go. Number 1. It's right off your assignment. Your assignment today is example 1. All of example 1. Okay? So that's your assignment. That's what we'll score tomorrow. That gives you 10 problems today. That should speak to how much joy you're about to have. Okay? All right. It actually is pretty fun, man. How many remember doing long division in elementary school? Love it. All right. So, let's talk about some steps here. Okay, now back in the day, in my first year and 2 weeks of teaching, I taught 5th grade. First year and 2 weeks. Okay, and then after 2 weeks, they transferred me up here they transferred me to the middle school because I had a math degree to teach math, which is where I wanted to be. They just didn't have any math openings. That was a joyous time, teaching 5th grade. I had Mr. Fountain, that's 2 weeks. It was amazing. Okay, now, we came up with, my first year there, or my 5th graders came up with a way to remember the steps for long division. Divide, multiply, subtract, check, and bring down. Those are I's. Kind of creepy. All right? Little cross. Now they came up with little ways of remembering it. Like theirs were dirty monkeys smell very bad. Okay, that was the one we came up with that first year. I thought that was a pretty creative one. Now, I know there's other ways to remember, and you may come up with your own, or maybe you had your own, but dirty monkeys smell very bad. I'm assuming it's true. I've never actually smelt a dirty monkey. But there you go. Divide, multiply, subtract, check, bring down. Those are the steps. Those are eyeballs, yes. Okay? Pretty happy about it. All right. Very good. So as we're going through this process today, we're going to follow those steps. All right. Number 1, use polynomial long division. Everyone remember how to do long? Who does not remember long division? Okay, let's do a very quick problem. 4 into 327. Okay? How many remember this?
Never mind, this is the stuff I liked.
All right. So 4 does not go into 3, right? You guys remember? Okay. 4 goes into 32. How many times? Okay, that's the divide. We multiply. 8 times 4 is 32. We subtract. We get 0. We check. We're checking to see if that goes into that. The answer is no. So we bring down the 7. And then we say 4 goes into 7. 1. So we start the division over. 1 times 4 is 4. We subtract. 3. We check. Hey, that doesn't go into that. And we bring down. And we don't have anything to bring down. So your teachers back then taught you to. First, they used this cool R. Remainder 3. And then eventually you had the mean teachers you thought were mean. They say, we just put decimals. And they make you keep doing math forever. Okay? And then you have the cool teachers, hopefully. I hope you had one of these teachers that said, no, really, you just take that remainder and you put the divisor under it, and that's your answer. Okay?
Oh, no. What?
Oh, you never had the cool teacher. I'm sorry. That's the answer. That's why you like fractions and not decimals. Unbelievable. All right. Well, so, need your attention back up here. Out of the 10 problems you're to do tonight, I plan on doing 6 of them with you. Okay? But that means we have to be working through them because like Vogel ran out of time in class. Okay? He came in and he was telling me all that right before I started your class. So the first thing you need to do, you need to understand that the thing you are dividing by goes on the outside. Now, I realized back in the day when you had this type of problem right here, and you had 327 divided by 4, and it was put out like that, most of the time you just said, well, the smaller number goes out in front. Okay? Well, that's fine. I mean, right here, hey, that's the smaller one. It goes out in front. However, when you keep going through these problems and you keep kind of looking down the page, the thing you're dividing by, like here's our assignment, look, these are about the same, they have the same number of terms. Same number of terms. You have to know the thing you are dividing by goes in the front. The thing that's being divided goes inside the division bar. Okay? So some of you have always just relied on the smaller thing goes out in front. Okay? You have to make sure you understand the thing you're dividing by goes out in front. All right. From there, you ask yourself, if there's only one term, it's pretty easy. Okay, there's actually a couple ways you can do this, but we're going to use polynomial long division. But you say, well, does 4 go into 12? Yes. The answer is yes, it goes 3 times. Okay, that's a 12, not a 1.2. Okay, 4 goes into 12 3 times. N squared times what is n to the 5th? N to the 3rd. Okay, right? When you're multiplying exponents, you're just saying you're adding the 2 likes, okay, to get into the 5th. Okay, so we divided there. 4n squared times 3n cubed is 12n to the 5th. So we multiply, we get 12n to the 5th. The next thing we do is we subtract. You get 0. You check, does that go into that? The answer is no. So you bring down. You bring down this whole thing. Now make sure you bring down the whole negative and everything. And then you continue with the process. 4 times what is negative 8? Negative 2. N squared times what is n to the 4th? N squared. Negative 2 times negative, or 4 is negative 8. N squared times n squared is n to the 4th. And now we look at it and we're like, well, hold on. That gives me a negative 16. However, you're really subtracting a negative 8, right? And when you subtract a negative 8, you actually are adding with, you get that? Okay. So we're adding the opposite, which really is 0. All right. We bring down 16 into the 3rd. 4 times what is 16? 4. Okay, and it's a positive 4, so that's a plus there. N squared times what is n cubed? N to the 1st. Okay, we multiply, we get 16n cubed. We subtract, we get 0. Nothing left to bring down. We are done. We have divided. Okay. Now that seems pretty darn easy, right? Now, if they were all that easy, we wouldn't be spending 3 days on this lesson. Now, let's be clear that you understand what's happened here. It's so easy sometimes just to do the math and go, well, I've got my answer. That's my answer. Okay, let's understand that what we're saying is we're saying that 3n to the 3rd minus 2n squared plus 4n, which is our answer in this problem, times what?
4n squared.
4n squared. So when we multiply that by that, we get
12n to the 5th minus 8n to the 4th plus 16n.
okay. That's what we're saying. So essentially, by dividing, we have factored. Correct? I mean, that's what's happened. So polynomial long division is a way of factoring our problem. We have factored. Now, could we have factored that easier than doing polynomial long division? Yeah, probably. I mean, many of you may just look at that and go, well, why didn't I just take 12n to the 5th minus 8n to the 4th plus 16n cubed and divided it by 4n squared? And then I could have just divided that by that. Yeah, just kind of reducing each part. You guys understand what I'm saying? Yeah. You could have. I mean, that would have been just fine. You could have reduced each part. You could have pulled out a 4n squared from each of those and ended up with 3n cubed, negative 2n squared, and positive 4n. It would have got you to the same point. In fact, it probably would have been faster. In fact, I probably would have done that if I wasn't teaching the lesson. Okay? But this was a good way to introduce you to polynomial long division. All right. Any questions there? So really, as I'm looking at number 3, since it's a single term, there's no addition signs in there, I would probably never use polynomial long division on this problem. I could set it up just like I've done over here. However, I think it's much faster to do this problem by actually reducing. So dividing by 3x squared y cubed. And it's set up very well since, it goes into it evenly. So I want you to divide this into each term up there and come up with what your solution is, and then compare it with your neighbor once you're done. All right, how many have an answer? Okay, let's see how we've got it here. Then check it out. So 3 goes into 9 3 times. X squared times x to the 4th is x to the 6th. And y cubed times 1 is y cubed, so we don't put anything else there. How many got the first term correct? Yeah. Very good. Okay, minus, because this is a positive and that's a negative. Okay, 3 goes into 12 4 times. X squared times x squared gives us x to the 4th. And y cubed times y gives us y to the 4th. How many got the second term right? Okay, and then the last one, 3 goes into 6 twice. And x squared times 1 is x squared, so we don't put any x squareds. Y cubed times y is y to the 4th. That is our solution. Okay, so we divided each part. This by that by that, and by that. Okay? We had to divide it by each piece. Any questions there? Okay. A little easier than polynomial long division, right?
Yeah.
Okay. So, if it's one term, I would go that route. All right? Okay. No questions. So we've done number 1 and 3. Some of you are type A'ers. Leave yourself some space for number 2 on your paper, maybe. And number 4, because we're now going on to number 5. Okay? Don't try to do 2 and 4 right now. Otherwise, you're going to be confused with number 5. Number 5, go ahead and write it out. You need to use polynomial long division here, so use your division bar. All right, now I hope you guys are using a pencil. Okay, what goes out here? 5x minus 3, very good. Let's see, what goes right here? And what goes here? Plus 9 goes here. What goes here? Come on, what are we missing?
Plus 0.
Why 0?
Because, I don't know.
You're right, plus 0 something. Yeah, we don't have our b term, so we have to fill it in. Okay? So you've got to have that place value holder in there. If it's a... So that seems like, the way we just walked through, it seems like a minor thing, but it's something some of you are going to forget on your test. I'm going to ask you to do polynomial long division and just demonstrate it. Most likely we'll have a term missing that you have to fill in. Make sure you understand that. Make a note of it. Highlight it. Whatever you do in your notes so that you study it later. Okay? You need that term. All right. So now it's a little tougher. I mean, back when you guys did long division, the single digit ones that went in were easy. Then they gave you double digits and triple digits, and, you know, it just messed with you. You just want to use your calculator. Okay? So we say 5, we don't worry about the 3. We ignore it. We just work with the 5x. So just the first term. 5 times what's 25? 5 times 5. X times what is x squared? X. Notice I have not messed with the 3 that's being covered up by the pen. I am saying that this goes into that. Okay? That many times. And now I multiply. 5 times 5x is 5x times 5x, 25x squared. And now we have to do 5 times negative 3, which is negative 15x. Notice I am lining up my like terms. Okay, that was one key piece where some students get lost. Make sure your neighbor understands what's going on. If you can't help them, then we need to ask a question as a group. Just talk to your neighbor real quick. You good on that? Yeah. You good on that? Any questions? All right. So from that point, the next place students get lost is right here. Divide, multiply. What's the next step? Subtract. Now I am subtracting a quantity. It's a key piece there. I'm subtracting a quantity. When you subtract a quantity, you're really adding the opposites. So that's really add a negative 25, and we have to switch this to a plus. Now some students just say, okay, I'm just going to flip all the signs when I go to subtract, and that's fine as well. You could have just changed the positive 25 to a negative, and the negative 15 to a positive. And then you got it. Okay? It's a key thing. Make sure you have that noted. Any questions on that?
So we
Flip the signs because you're subtracting a quantity. It's like distributing a negative 1 in. Okay, and we'll see that again on the next problem. But Right here we get 0. And here we get 15x. Does this go into that? Well, it's hard to check. I mean, we know that this goes into that, but there's nothing for the 3 to go into. So we won't have two terms until we bring down the 9. Now we have two terms. And we can continue our process. Remember, we ignore the 3. 15x, or 5x times what is 15x? 3. So it's plus 3. And now we multiply out. 3 times 5x is 15x. 3 times negative 3, negative 9. When we subtract, really we're adding the opposites or flipping our signs. Okay, so this becomes 0, and this is 18. Now, there are two terms here, so we have to have two terms here. That's our check. Are there two terms? Nope, and there's nothing to bring down. So this becomes our remainder. Now, we just talked a minute ago about the amazingly cool teachers that taught you your remainder actually goes over your divisor. That's your answer. Which means this problem, 5x minus 3, does not go into this quadratic evenly. You have a fractional remainder. You have a rational function. And for those of you that hear me talking about chapter 8 all the time, you're like, why is that so tough? Because in chapter 8, you are graphing this.
Oh boy, that sounds like fun.
Okay? All right. Let's enjoy. Not as bad as it looks. It's pretty cool. That's our solution, though. Any questions? Tyler?
Can you simplify the solution?
Right here? I can't simplify, no. Any other questions? All right. Everyone try number 7. Get as far as you can. Hey, hopefully everyone set it up correctly. Question needs to go into, r goes into 3r squared. We ignore the 3, this 3 again. R goes into 3r squared 3 times, so 3r. Okay? 3r times r is 3r squared. 3r times 3 is 9r. Okay, we subtract, which means we need to flip these signs. That gives me 0. That gives me negative 2r. Okay, we have two terms. We have 1, so we need to bring another term down. Any questions up to there? How many are still good up to there? Okay. R times negative 2r. Okay. That gives us, r times negative 2. Okay. Negative 2 times r gives us negative 2r. Negative 2 times 3 is negative 6. We subtract, meaning we flip the signs. That gives us 0 and 2. It's a positive 2 as a remainder, which we put over our divisor. Any questions? Okay, everyone rate yourselves 1 to 5 right now. All right. Okay. Let's go ahead and move on to the next one. Any questions before we go on? Tyler? You're just giving me a high five? All right, there we go. Next problem. This is number, sorry, I zoom out. It's such a big problem. Number 9. Talk to your neighbor before you copy this one down. Talk to your neighbor about what you need to do first. Here, what do I need to do first? Yeah.
Put
Yeah, put it in standard form. Okay? So we have an x to the fourth, no other x to the fourth, so that's our greatest. We have x cubed and no other x cubes. We have an x squared and no other x squareds. It's a negative. We have a 13x and we have a negative 2. All right, so we've got all of our terms there, and that's our divisor there. We haven't missed any degrees there. And then we have x squared minus 4x plus uno. Holy moly. All right. What should we do first?
Cry.
All right, other than crying. Hey, really, when we're looking at how many times this goes into this, what do we focus on? Someone said it. The first term. We just look at the x squared. Now I'm running out of pens. Hopefully we don't get too many more terms out there. Okay? We look at the x squared. X squared times what is x to the fourth?
X squared.
X squared. And all that's all we do. And then from there, we go and multiply. X squared times x squared is x to the fourth. So times that, and then times this. X squared times negative 4x. Negative 4x cubed. And x squared times 1 is x squared. Now that's why we have to have place value holders up here if they don't give us one of these degrees, because then they wouldn't line up. Okay? Now we subtract. Now when we subtract, you got to flip all the signs. Negative, positive, negative. Okay? That gives us 0. Gives us 7x cubed. Gives us negative 22x. Huh? Oh, 5. Sorry. Man. Well, at least I know you guys are following along. Good. 5x cubed. Good job. All right. Our check. There's 3 terms. There's 2 terms. We need one more term.
Wait, it's not, if we're adding the x squared, it should be negative 20 x squared.
But you had to change that sign.
Oh.
Right. So bring that down. 13x. Tell your neighbor what your next term is going to be up here. I know it's fun. Good job. Yeah, said it was fun. He loves it. All right. Okay, what is it? Go for it. Take a guess.
5.
It is 5x. Yep. 5x times x squared is 5x cubed. So that's what you're seeing. What times this makes that? Right? What times this makes that? Did you still have a 7 there?
Oh, no.
Oh. All right. Figure it out? So we get 5x cubed. And then 5 times negative 4x is negative 20x squared. And then 5x times 1 is 5x. And we subtract, which means we are adding the opposite. So we make this negative, positive, and negative. Becomes 0, negative 2x squared, and 8x. 3 terms, 2 terms, so we need to bring down that last term. I want you to finish up the problem. Okay, here we go. X squared times negative 2x, or negative 2 is negative 2x squared. It gives us negative 2x squared. Negative 2 times negative 4 is positive 8x. And negative 2 times 1 is negative 2. We flip the signs. That gives us 0, 0, and 0. Here we got it, man. This is our solution. How many got it? Now, let's see if we can make the connection here. Remember, this means if I want to factor this, you do not know how to factor x to the 4th plus x cubed minus 21x squared plus 13x minus 2. We haven't learned how to factor that. However, you do now know that x squared minus 4x plus 1 times x squared plus 5x minus 2 equals that. And you know how to factor both of these. So you could actually solve for x now by doing that. Everyone see that? Okay? Yeah. Well, you can't factor that one, but you use quadratic.
On the homework, do we just like find the answer to the long division? Or
You just right now, as of today, you're just finding this.
okay.
Remember, example 3 is where you're doing the rest.
Okay, cool.
Okay? So in example 3, you're finishing. Okay, today we're just coming up with this piece. All right, any questions? Last one, number 10. What time we got? Oh, yeah, you guys. Make sure it's in standard form first. Looks like 4th degree is the largest degree. I'm going to write it over here. Looks like we got a 7n squared, or cubed. Negative 3n squared. 2n minus 8. All right, get as far as you can. Okay, so those of you, you're working on it, just check your work. N squared times 2n squared. Oops, gives you 2 into the 4th. Then you multiply 2 into the 4th. So that times that, that times that. 6n cubed and negative 2n, or negative 8n squared. Subtract, which means flipping our signs.
Yeah.
No. But I can get 1, 3, 5, 7,
Finishing this problem that will have a goal.
1, 2, 3, 5,
Just
7.
kidding, it's not gonna happen. Oh, once you get finished. Yes, I got it.
Do it. Quick.
Got it.
Hey, there's our solution. 2n squared plus n plus 2.